Hello and welcome. Today, we're going on a journey, tracing the long and honestly pretty surprising path a medicine takes, from, say, a simple discovery in nature, all the way to that bottle sitting in your pharmacy. It is a story of incredible science, really high stakes, and some truly life-changing breakthroughs.
I mean, really think about it. It's so easy to take them for granted, right? But behind every single one of those pills is a story. A story that probably involves decades of research, billions of dollars, and, countless failures. So where does that story even begin? Well, for a very long time, it didn't start in some high-tech lab. It started in the world all around us. You see, for most of human history, our best medicines weren't really invented. They were found. They were hiding in plain sight, in the bark of trees, the petals of flowers, and even in common household mold. We have been tapping into nature's pharmacy for thousands of years. The ancient Greeks, they knew to chew on willow bark for pain relief. The powerful heart drug, digitalis, it comes from the beautiful but pretty poisonous foxglove plant. And maybe the most famous of all, the entire antibiotic revolution kicked off because Alexander Fleming accidentally discovered penicillin in a little patch of mold. And this is a perfect example of that bridge between ancient wisdom and modern chemistry. Scientists figured out the active ingredient in willow bark, salicylic acid, but turns out it was pretty harsh on the stomach. So by tweaking its chemical structure just a little bit, they created what we know as aspirin. It's basically nature, perfected by science. And this really marks a fundamental shift in how we do things. While nature still gives us a ton of inspiration, modern medicine is all about creating pure, synthetic versions in a lab. This gives scientists precise control and, of course, allows for mass production. But, and this is a big but, creating a promising molecule, that's just the very first tiny step. Proving it's safe and that it actually works for humans, that's where the real challenge begins. Every potential new medicine has to survive what you could call a brutal gauntlet of testing. Seriously, for every single drug that makes it to the pharmacy, thousands, and I mean thousands, fail along the way. This whole process is designed to answer a few absolutely critical questions. Okay, so it really boils down to three core things. First, and this is the most important one, is it safe? Is it going to do more harm than good? Second, is it effective? Does it actually do what we hope it'll do? And third, what's the perfect dose? Because too little is useless and too much can be dangerous. Let's just focus on that second point for a second, effectiveness, or what scientists call efficacy. This is the million-dollar question. It's not enough for a drug to just be safe. It has to be proven with hard data that it actually makes a measurable, positive difference for patients. So how does scientists get those answers? Well, it's not by guessing. They use this meticulous, multi-stage process of trials where each step is designed to build on the last one and really put that potential medicine through its paces. Okay, first up, we have preclinical trials. This is all in the lab. Scientists are testing the compound on cells in a petri dish using computer models to predict what might happen. The vast majority of drug candidates fail right here. Now, if a drug shows promise, it moves to animal trials to see how it behaves in a living system. Only the safest and most promising candidates from that stage ever make it to human clinical trials. And even when a drug finally gets to human trials, safety is everything. The first human volunteers get an incredibly small dose, one that wouldn't even have a medical effect. The researchers are just looking for any bad reactions. Only when that's proven safe do they cautiously, step by step, increase the dosage to find that perfect balance, that sweet spot that is both safe and effective. Now, you might be thinking, this process sounds incredibly thorough, but man, it also sounds incredibly long and expensive. So why? Why all the red tape? Why the extreme caution? Well, the answer is rooted in a tragedy that sent shockwaves through the entire world and changed medicine forever. We have to talk about thalidomide. This single drug disaster in the mid-20th century completely rewrote the rules for drug testing, and its story is why we do things the way we do now. It's a tragic story. Back in the 1950s, thalidomide was sold as a safe sedative. It even seemed like a miracle cure for morning sickness, so it was widely prescribed to pregnant women. But by 1960, a horrifying link was discovered. The drug was causing catastrophic birth defects. The strange thing is, the drug itself wasn't totally useless. Today, it's used under extremely strict rules to treat diseases like leprosy and bone cancer, a pretty stark reminder that context is everything in medicine. The damage was chillingly specific. If an expectant mother took the drug during a really critical window of development, often before she even knew she was pregnant, it had devastating consequences. It led to babies being born with severely shortened or even missing limbs. The global human cost was just staggering. More than 10,000 babies were born with these life-altering conditions. And that number, it serves as a permanent, chilling reminder of what happens when drug testing isn't good enough. So this brings us right to the critical lesson from this entire story. The exhaustive, expensive, and time-consuming process that we have today, well, it wasn't designed in a vacuum. It was forged in the fire of this tragedy. The thalidomide disaster was the wake-up call. As a direct result of what happened, governments and medical authorities all over the world were forced to completely overhaul their systems, making drug testing far, far more rigorous than it had ever been before. So every single safety check we've just talked about, from the cells in the lab to the phased human trials, every single one is a direct legacy of thalidomide. The safety that we often take for granted today was built on the lessons learned from that incredibly painful history. And this really leaves us with a profound question, one that doctors and scientists still grapple with. In a world with fast-moving diseases and urgent medical needs, how do we strike the right balance? We all want life-saving cures to get here as fast as possible, but we also demand and deserve absolute safety. Finding that balance between speed and certainty, well, that remains one of the greatest challenges in modern medicine. Thanks for joining me.